Now, what we're going to look at today is something called composite functions, or composition of functions. So here, the composition of a function g with a function f is this. They're going to define it as h of x, as a new name for the function. But the way that we say this here in mathematical terms, so this here, we call this g of f of x. G of f of x. Because if you think of a normal function, we talk about f of x, f taking whatever that value is. But here we have g of the function f of the function x. So when we talk about x, when we take f of x, we're trying to find out what value of x we can plug into the function to get the output, the value of y. And so what we're doing is something like this here. I have an input, our x values. So we talked about a normal function. We plugged a value in and got a value out, yes? So the input, we're plugging it into f. Now the value we get out of f, we're plugging into g and seeing what that value is. So really what we're doing is we're plugging something into the function f, and whatever we get out of it, we're plugging into the function g, and that's what our new term is. It's doing functions twice. Now let's actually look at this here, and it's going to make more sense when we actually start working with it than it is mathematically thinking about it. F of g of x. Now when we do these here, it's going to seem a little weird because the first step's not going to change much. But when we talk about functions, really, we're plugging whatever's inside of here into g, because normally if we just plug x, we just get x. So g of x, well, g of x is what? X squared plus 3. So when I plug x into g of x, I get x squared plus 3, yes? So g of x is x squared plus 3. So when I plug x into g of x, what I get out of it is x squared plus 3. Well, if I had plugged a number, we would have gotten whatever that is. So 1 would have been 1 squared plus 3. So any questions on this here? Now with this composite function, we're going to take what we got out of g of x and plug it into f of x. But this time I'm not plugging in x. What am I plugging in? The x squared plus 3, because that's what's taking the place of x, yes? So instead of plugging x into here, we're plugging in x squared plus 3 for every place that x appears in f of x. So here we would have x squared plus 3 plus 2. So we'll need to simplify a little bit before we can say we're officially done. So is there anything going on with those parentheses around the x squared plus 3? No signs out in front, no numbers in front of it? No powers, it's pretty much just by itself, yes? Okay, so we can drop those. Do we have any like terms? 3 and 2, which gives us plus 5. So f of g of x would be x squared plus 5. Questions on this here? Is this kind of making sense how we do this here? It's one step to the next. Okay. Now we're going to go the other direction. We're going to go g of f of x. Because on the last one, we went f of g of x, yes? Do you think this will change how it looks? Probably, yes. So let's start out from the center. Because with any of these composition functions, no matter how many we have, we always start from the inside. We always start where the middle x is. So f of x, if I plug x into f of x, what do I get? X plus 2. Okay, now what do we do next? Yes, now we're going to plug this into g of x. For everywhere there's an x, I'm plugging in x plus 2. So that would give me x plus 2 squared plus 3. Well, x plus 2 squared is the same as x plus 2 times x plus 2. And yes, I know that I can kind of see that thought in your head. We're going to have to multiply these out. We're going to have to simplify this all the way down. So let's go on and do that. We're going to distribute the x. Because x times x would give us x squared. X times 2 is going to be plus 2x. Do the same thing with 2. 2 times x is going to give us plus 2x. And 2 times 2 is going to give us plus 4 plus 3. Because we're going to have to multiply this all the way through. Okay. Now we can call it good as long as there's no like terms, but are there like terms? Well, x squared is by itself, but what do we have? 2x's, which gives us 4x. 2x plus 2x is 4x, plus 7. So g of f of x is going to give us x squared plus 4x plus 7. Questions on this here? Are we good with this here so far? Yes? Not as gross as it might be. Or it's not as gross as you think it's going to be. So let's work it out and see how this goes. So f of g of x. Well, what is g of x? Because when we plug x into g of x, we get 2x minus 4. Well, next we're going to take 2x minus 4 and plug it into f of x. Well, that would give us the cubed root of what? All inside the cubed root. Right, because there's nothing really being applied to the parentheses. We don't have, it wasn't like 2x, so we're not multiplying it by 2. It's not squared. There's nothing going on with it, so we can drop those parentheses, which would give us 2x minus 4 plus 1. And if I combine like terms, we get 2x minus I mean, that's as simplified as it gets. Because, I mean, if we could rewrite that as something to the third power, then we could simplify it. But 2x minus 1, or minus 3, There's no way to simplify that. There's no way to simplify those radicals. That is as simplified as it gets. So it wasn't as gross as you might think it could be. Yeah. There's a good chance that they could get gross. Yes. The next section, they can get a little messy. All right, now we're going to look at it the other direction. G of f of x. So now we're going the other direction because we did f of g of x with radicals. Now we're going to do g of f of x. So we're on the top of page 2. So the first thing we want to do is plug x into f of x. And I'm not going too fast, am I? Okay. And if we plug x into f of x, we get what? The cubed root of x plus 1. Now what we're going to do, we're going to take this and plug it into, and what would we have? Minus 4. Right, so in each one of these steps, we're just plugging in what we had. So first we plugged x into f of x, and we got the cubed root of x plus 1. Then we plugged that into g of x, and got 2 times the cubed root of x plus 1. Yes? Now when we multiply by a cubed root or by a radical, if the radicals are the same, we multiply what's inside. Yes? So will the 2 go inside that radical? Is the 2 in a cubed root? Well, no, because it has to be if we have things inside cubed roots. So I'll write it over here. So if we had like this cubed root of 2x times the cubed root of 7, then we can do 2x times 7 because they're both inside radicals, yes? But here, do we have that? No, so we just multiply the cubed root of x plus 1 by 2 and get times the cubed root of x plus 1 minus 4. Can we simplify this at all? No. One's actually very useful. Because if you divide anything by itself, so if we don't have it, we can't divide anything by itself. Because 1 is the identity for multiplication. It is also the additive identity to itself. 1's actually very useful. Yeah. Yeah. 0 is also very useful. Are there any questions on this here? Do we feel good with this here? Yes. We want to see more? Yeah, that's fine. Yeah. Yes. F of g of x. F of g of x. So, the first thing we want to do is we want to plug x into g of x. And g of x is? Right, plugging x into g of x really just feels like we're plugging in 3x plus 5, but essentially that's what we're doing. But since it's already defined by x, g of x, it doesn't really change anything. Now, if it had been g of 1, it might look a little different because instead of plugging in x to g of x, we're plugging in 1. And we'll see that here in a minute. But we get this part here. Now we're going to take f of 3x plus 5. So we're going to plug x plus 5 in for x, every x that appears in f of x. So that would give us 2 times 3x plus 5 plus 7. So we're plugging that in for every spot where x is. Any questions on this so far? Now all we need to do is we need to simplify this here. And we're going to do that by distributing the 2. So 2 times 3x would give us 6x. 2 times 5 is going to be plus 10 plus 7. Well, 10 plus 7 is 17. And that's it. Questions on any of this here? All right, let's look at it going the other way. G of f of x. G of f of x. So this time, we start with f of x. It would be our two x plus 7, because when I plug x into f of x, I get 2x plus 7. Now what we've got to do is we've got to plug 2x plus 7 into g of x, which would give us 3 times 2x plus 7 plus 5. Now again, we're wanting to simplify this down, so we'll need to distribute the 3. We need to multiply through by 3. Well, 3 times 2x will give us 6x. 3 times 7 will give us plus 21 plus 5. Now at this point here, we need to combine like terms. So we would do 21 plus 5, which would give us plus 26. And this here would be our g of f of x. Questions on any of this here? We feel comfortable with this here? Yes? For the most part? We're going to look at these. So these here are a little bit different. I wouldn't say more difficult. But this time we're not looking for f of g of x or g of f of x. We want to find what? F of g of 3. So now we're going to actually find a value for it. And again, when we started with all the every single one we've done today, we've worked from the inside out, because we started with plugging x into g of x, and then plugged that into f of x and found out what f of g of x was. Yes? We're going to do the same thing here. But this time, instead of plugging in x, we're plugging in 3, yes? I'm going to plug 3 into g of x. So every place there's an x, we're plugging in a 3, which would give us what? 3 squared. I don't know what was up with that parentheses. Yep, there goes the board. 3 squared plus 2. Lovely. Yeah, the calibration went a little funny. So, what we started off with, so f of g of 3, so for g of 3, we plug 3 in for every place there's an x in g of x. So any questions on what we did for this first step? Now, I'm not going to move on to the next step of plugging it into f of x until we get that kind of simplified down. Because can we simplify 3 squared plus 2? Oh, yeah, we can simplify that down. Why not? Do that before we start trying to plug it in for f of x. Because what is 3 squared? Yeah, you're good. Because 3 squared is going to be 9, and 9 plus 2 is 2. Now, could we have pulled a calculator out and done parentheses 3, close parentheses squared plus 2, and hit enter? Yeah, and it had told us it's 11. We could have typed it in. That's perfectly fine because everything inside of here is a number. We don't have any variables. So we could have typed that all in the calculator and told the calculator to give me my answer, and it would have done it. Now we have f of 11. So what are we going to do? We're going to plug 11 into our f of x because we have f of 11. So in f of x, every place there's an x, we're going to plug 11 instead, which would give us what? So 3 times 11 is minus 4. So f of g of 3 is 29. Yeah, well, no, it actually would have given you the same thing. I'll show that here in a second. Are there any questions on this here? So we good with this here? Yes? Now, the reason I say simplify it down, and I'm going to erase this here and kind of show that. Now, no, it's fine. Seeing this is good. Because we could plug this in for x, for f of x. Now, what that would give us would be 3 parentheses, 3 squared plus 2 minus 4, which still works. We can type that all into the calculator. But the reason I shy away from this is because when we get into more and more, kind of if we have radicals and roots, and if it was radicals and squares, we have a lot of stuff going on all at once. And I feel the least complex, if we can make it simpler, it's going to be easier to work with. Because at this point here, we would have to do 3 squared plus 2 minus 4. It was 3 times 11 minus 4, which would be 33 minus 4, which is still 29. So it's adding more steps. It's not as adding steps. It's just less that we have to try to keep straight in our head. Yeah, because you can do that. It would give you 3 cubed plus 6, and that would work. But it's keeping track of all of our variables, or all the numbers, and making sure we're using the properties correctly. We're going to, yes. Mm-hmm. All right, this is the next one we're going to look at, g of f of -1. We're going to start in the inside and move out. So to start off with, we're going to plug -1 into f of x. So any place there's this x in f of x, we will plug in -1, which will give us 3 times -1 minus 4. So we're just plugging -1 into f of x. So 3 times -1 would be -3. Running out of room. And well, negative 3 minus 4 is negative 7. Any questions on how we got to this point here? Now we're going to plug negative 7 into g of x, which would give us negative 7 squared plus 2. Yes. Because negative 7 times negative 7, well, the negative and negative make a, and 7 times 7 is 49. 49 plus 2 would give us 51. So g of f of negative 1 is 51. Questions on this here? How do we feel with these here? We feel good with these here? Yes? Okay. Let's see what we have. Okay, we've got these. Okay. I want to go to this one here, and I'm going to go a little bit off the note sheets because I want to throw a little bit of a screwball with this. Because we could do this with x. The next one I'm going to write up here because I'm not doing, I'll use 0. Let's go with 0. But we're not going to do f of g of 0 because there's other things we can do with this. Let's say we're going to take g of 0. The last one at the top. At the bottom, yeah, 4x plus 7 and 3x plus 5. So, again, when we work with these here, we always work from the inside out. Yes? Bless you. So we're going to start out with g of 0. So I'm going to plug 0 into g of x, which would give us what? 3 times 0 plus 5. Well, 3 times 0 is plus 5 just gives us 5, yes? Now we're going to do it again. So this time we're going to take g of 3 times 5 plus 5, yes? Well, 3 times 5 is? Huh? Okay. So what have we got so far? Okay. So does it make sense up to this? So where'd you get lost? Or kind of where did it stop making sense? This here? So where we got the 5? So 3 times 0 is plus 5 would be 5. So now I'm going to start kind of here. So we have g of 5. So I'm going to plug 5 into g of x, yes? So g of x is 3x plus 5. So we would have 3 times plus, which would give us 15 plus 5. You're good? Yeah. And 15 plus 5 is 20, yes? Well, now I'm going to take what? G of 20. Well, so that would give us 3 times 20 plus 5, because g of x is still 3x plus 5. Well, 3 times 20 is? So g of x is 65. Because there's nothing that restricts us from doing this only once. We can do this multiple times. So we can do it more than once. We can do it a few times. Mm-hmm. So questions on this here. So that means we could also do f of g of f of g of f of g, and just keep switching those a whole bunch of times and do the same thing.
What's the purpose of that?
It's just how we're compounding stuff. This is actually somewhat useful. Some of you have used this before.
So is there going to be someone who use this right at all? That was the story that did help with the figure out.
You all receive coupons in the mail like this year. You get a coupon for whatever store. That's 15% off the total amount as long as you a whole bunch of stipulations. Yes? So what this is saying is that, I'm going to call it f of x, is going to be, so 15% off, we can define it as 0.85x, because normally you take 15% off something, you subtract it from 100, which would be 0.85, yes? But we also have sales tax. I think in Oklahoma it's 8%. It changes depending on the product. So we can set g of x as 1.08x. Yes? So really, whatever my total sale is would go into f of x first. And then we would take that amount and put it into g of x, yes? So really what we're saying is that I have g of f of x. This is our composition function. And based off the diagram we started with, where we had these three circles, our cost, this here would be our total cost, then I would get the cost with the discount, yes? And then we would take that value, because this is our f, add sales tax to it with g, but from here to here would be defined as g of f of x. And doing some of these here is if you're applying multiple discounts or multiple taxes where these multiple uses of different functions get combined and used together, this is essentially what they're doing in those systems. Yeah. But that's it with these here. Now, there are certain cases where f of g of x, f of g of x will be the same as g of f of x. There is a case where these will be the same. And what they'll work out to be is x. G of f of x will be the same as f of g of x, which will be the same as x. And we call them inverses. And that's what we're going to talk about in the next section, is these inverse functions. So this here, f of g of x and g of f of x, if we can show that these are true and they both equal x, then we can say that the two functions are inverses of each other. And that's about it. This here, f of g of x and g of f of x, is to test to see if the two are inverses. And before we officially wrap this up for the day, there's one notation that they didn't include in this here that you'll sometimes see this as. And it looks like this here. It's going to be a little circle with an open circle. And all this is saying is that this is f of g of x. So this here is g of f of x. And they kind of jokingly call this fog and goth, because it looks, f of g of x looks like fog, F-O-G, and goth, G-O-F. But f of g of x and g of f of x.